I think we're at the state, so I was hoping that would, I always hope things will, the thing about being an optimist is that you always think things are easier than they actually end up being. But that means you actually try things that you sometimes end up succeeding at. So let's see how far. I think we could have done 2 levels of this game. Let's get 1 level. So more on sequences. There's something called the algebraic limit theorem that says if A and B are sequences and A has limit L and B has limit M, then if you multiply A by a constant, it also has a limit, and the limit gets multiplied by a constant. If you add A and B, that adds the limits. If you multiply A and B, that multiplies the limits. And if you divide A and B, that divides the limits, as long as the denominator is not 0. Okay, let's do one instance of this, which is the easiest version. I'm not going to read all of this text. You're welcome to read the text about the factory worker. We have 2 sequences, A and B. We know that A goes to L, and we know that B is equal to 2 times A. And we want to prove that B goes to 2L. Okay, that's our goal. So let's see if we can do this. How quickly can we do this? What does seqlim mean? For all epsilon. We could write change, or we can just know in our mind that it starts with for all epsilon, epsilon positive, and just say, give me that epsilon. So that is intro. So intro epsilon, and the fact that epsilon, maybe I should call this epsilon positive, eps pos. Okay, so now we have an epsilon. We know that epsilon positive. We need to prove that there exists an n so that b of n minus 2 times L is less than epsilon. Where are we going to get that n from, Amy? That's a good guess, but I have no control over the Archimedean property is if you know that you want n to be at least 1 over epsilon or something. Exactly. Okay, so you want to change what H says, or you want to just specialize H? What do you want to do? Okay, so change for all, let's give this a different name, delta positive, just so that we don't confuse the dummy variable there. That's a very good thing to do. There exists a capital N1. Maybe, do you guys mind if I put subscripts? So that for all n greater than n1, absolute value of a n minus L is less than what I call a delta, and make that change at H. Okay, so now H says for all delta positive, there exists an n1, so that for all n greater than n1, a n minus L is less than delta. Very good. That's the whole point of using a different dummy variable. If I stick in epsilon here, then I'll be able to show that an minus L is less than epsilon. But what I actually want to know is that 2n minus 2L is less than epsilon. So this is where the scratch work ahead of time says, oh, I'm going to want to divide this equation by 2 and say 2n minus 2L is less than epsilon is the same thing as an minus L is less than epsilon over 2. So actually, I need to set delta equal to epsilon over 2 in order to get what I need. Okay, does that make sense? So specialize H to epsilon over 2. Well, that means that I'm going to say if epsilon over 2 is positive, and that's not exactly what I already have. So I need to declare that epsilon over 2 is positive. So have fact F1 is that 0 is less than epsilon over 2. Why is this going to be true? Bound should do it. Hopefully bound actually did it. Yeah, bound actually did it. Again, there's bugs that we're working out. Okay, so now I have this fact. Specialize H to F1. And now I know that there exists some N1, so that for all N yada yada, choose N and the hypothesis on N using H. Okay, so now I got my capital N, and I know that for all n greater than capital N, an minus L is less than epsilon over 2. Use n. That's exactly the n that I want to use. Now the goal says for all little n greater than capital N. Intro little n and hn. And now I have my little n, and I have the hypothesis that little n is greater than capital N. Specialize, bless you. Specialize h capital N to little n and the fact that little n is greater than capital N. Everybody following along? We're starting to get the payoff. Okay, so now I know that an minus L is less than epsilon over 2. My goal is to show that Bn minus 2L is less than epsilon. Let's specialize first. Let's specialize, what is it called? B scaled to n. That's the, for which n, it used to say for all n. Which n do we want this? We want this for the little n that we have. Now we rewrite B scaled at the goal. And now I have A 2 minus an minus 2 times L is less than epsilon. Very good. So have fact 2, which is that this is equal to 2 times that. Why would we need to do that? Because lean doesn't do it by itself. That's true. Okay, so here's this fact. The new theorem that this level wants to teach you is Abs-Mull. And Abs-Mull is that Abs-Mull says the absolute value of A times B is the absolute value of A times the absolute value of B. So that's why you want to group the two. You want to factor out that factor of 2. Now what? Rewrite F2. Okay. Beautiful. Have fact 3, which is that this is equal to that with absolute values by apply Abs-Mull. Okay. Rewrite F3. Okay. Yeah, let's see if norm num does it by itself. It does. And now you could, this is already linear arithmetic. This should be linearith just given hn. It should know 2 is a constant, so it should be able to divide through by 2. Let's see. Linearith hn. Okay, you guys see it? Yeah.
Can you explain what because I just don't actually.
Yeah, so is there some scalar multiple of this inequality that gives us that inequality?
Scale, okay.
Yeah, linear arithmetic is like in a vector space. So linearity in a vector space, you can add inequalities, you can multiply them by scalars, where the scalar is 2 in our case. Jeff.
Could you also do like, instead of linearity on the last line, you just do like have F4 equals, and just like the goals, and then it's the goal statement by applying channel.
You want to say have F4 and then the goal state? Okay. By apply HN. Okay, so that won't work. The reason it won't work is because how am I, HN is not it's not exactly the same thing. And it's not a theorem. Suhas? Bound will probably work. Bound will probably also work. So let's just try bound. Bound alone. Yeah. Bound is, I didn't want to have to teach you linearith. I just wanted you to use bound, but bound doesn't always call linearith in the right way. And sometimes it gets stuck. So I had to teach you linearith also. Okay. So field simp at HN. Let's see if that'll do something. So let's try field simp at HN. Will that cross multiply? It did. And unfortunately, okay, so now you could do ring to move them back around. Yeah, there's a variety of ways of finishing it. Bound is probably the easiest.